Please welcome Adam Flanagan, the Creator Fund.
I'm Adam Flanagan, an associate at Creator Fund and board observer at Solve Chemistry. We're proud investors in Solve, having backed Jose and Lyndon at pre-seed as their first investors. We were excited by their mission of solving chemical scale-up and by their combination of technical rigor and earned commercial insight. The progress since the pre-seed round has been fantastic, building out their lab at Imperial, hiring a great team, and most importantly, delivering real value for their customers. We're excited that with their recent seed round, they'll be able to scale their product to the world's leading chemical giants. We're very proud to nominate them as part of the Falling Walls Science Summit.
Breaking the wall of unpredictable chemical reactions. Jose Pablo Folch, Solve Chemistry.
Hello everyone. My name is Jose Pablo Folch, and I am the co-founder and CSO of Solve Chemistry. And we are a one-year-old spin-out from Imperial College London that was created because AI, as you have heard, has revolutionized discovery. And now we see more molecules, more drugs, more materials being brought to market every day and being discovered. However, we don't believe that value is created when you discover something, but it's delivered once you finally get it to the market. And unfortunately, the science of scale-up has been left behind by AI. Stuck in this loop of constant re-optimization that can mean that things that are ready nowadays will not see the market for many, many years. We believe there is a better path, one driven by predictive chemistry and modeling of these physical systems that will allow us to reduce this long process into just a few months. However, we cannot really do this without the data. The data just doesn't exist to unlock this path. And just like AI has revolutionized discovery, Solve is going to revolutionize scale-up. More new chemicals, faster, more sustainably, and less expensive. Our approach is data first. However, we cannot just use any data. We want to use the best data, collect it most efficiently, and maximize the insights we get out of this data set. We begin with Bayesian experimental design, which was the topic of my PhD, and we use this to select the data that's going to give us the most information out of to our models. We then collect this data very, very efficiently, up to 10 times more efficiently than industry standards, using techniques developed by my co-founder Lyndon during his PhD. Finally, we want to maximize the insights out of this data. And to do that, we use interpretable machine learning that understands chemistry and is able to really unlock insights into the deep chemistry that happens. We do this in a fully automated lab in order to really be printing out this data as much as possible and have as little human intervention. And the data is fully machine learning readable. We also collect this data in ideal heat and mass transfer conditions, which means that we are unlocking actual chemical insights that are scale independent. And that's where we can inform the whole scale-up process. We currently offer 2 data products. The first one is just a standalone one-time data collection of we create one high-quality data set in a reaction of the client's interest. And the second one is a recurring contract of at least 3 months, where one of our systems gets completely assigned to a client. And we constantly develop new data sets for them and new models and new insights in any reaction they want. Finally, we're currently building a software product where we are collecting a very large amount of data internally. And this data set will power a software product that will allow people to get access to our insights and to our models directly from software. The market opportunity we're tackling is huge. Agrochemical R&D spend in scale-up in small organic molecules was 3.6 billion. And if we include pharmaceuticals, we go over 11 billion. If we have planned expansion into materials and biologics, this could unlock markets of almost 70 billion. We currently have already gained traction, selling our what we call Island, which is a single project, and our Archipelago projects, which are the recurring projects, to large pharmaceutical and agrochemical companies, as well as working with equipment manufacturers. We have managed to break the 6-figure revenue already, and we are working to make these contracts long-year contracts that could bring in 7-figure revenue. We also stand in a very unique position in our competitor landscape. We are the only hardware-enabled software company operating so close to production scale. I would argue that our biggest competitors are the internal teams of these big pharmaceutical and agrochemical companies. However, they have very bad siloing, which means they will struggle to get our level of automation and machine learning across the whole spectrum of the reactions. And in addition, they cannot collect data fast enough. We had one of the lead labs visit our site, and they were shocked to know that when they can collect 30 data points of this high quality, we can collect 500 a day. We have built a strong team with expertise in machine learning, automation, and flow chemistry, with expertise from Oxford, Imperial, ETH Zurich, and Leeds, and as well as industrial experience that's very relevant to the industry from BASF, AstraZeneca, and Pfizer. We are currently focusing on building out our software product, industrializing sales, so building a proper sales team, and finally increasing our capabilities and capacity so that we can generate as much data as we can and also increase the amount of reactions that we can cover so that we can unlock larger markets. I would like to thank you for your attention, and I'm happy to take any questions.
Thank you. Let's go for questions. 4 minutes to go. Who would like to start? Iris. This is the question corner here,
Thank
right?
you. Until what scale will you actually try the new recipe or new molecule?
So we don't do discovery. We assume the recipe is already made, and then the question is how you can actually scale it up to manufacturing conditions in an efficient manner. So that's when we come in. Currently, that process is optimizing in a small lab, then optimizing slightly bigger, so optimizing slightly bigger, and it takes a very long time. We help speed up that process at the moment.
But your customers would still be the one to do it at like kiloton scale?
Yeah.
Okay, Stefan or Luca? Go on, Stefan.
Okay. One of the key problems supposedly is to get the data and also building trust around the data with your customers. How do you acquire the data, and can you then later scale about it? Because typically you may end up in a monolithical situation with one customer for one specific problem and then have to abandon all the rest of it. How do you go about the data?
Yeah.
Where do you get it from?
So we have an automated lab in London. So we create all the data. And we try to work with as many clients as possible to avoid this. We wouldn't just work with one client. We have a lab that we currently expanded with 10 systems, so we can assign a system to each different client and work on different types of reactions.
Same question. So let's go to Inga.
So thank you very much. So how many licenses could you sell, for example, at BASF? So how many seats do you have in a company?
So currently we haven't built a software product, so we're figuring out how to price it. But ideally what it would be is we would charge per model created. So what would happen is you would be interested in a process, in a specific reaction. You go to our software, and we provide a lot of information that from that process. And those insights we charge per use instead of per seat.
Great. Next questions, comments? Audience, this would be your moment. Yes, we have someone in the audience. Last row, fantastic.
Yeah, thank you very much. Is it also considering safety when scaling up, or is it only the efficiency of direction?
We're collecting data, so we're trying to maximize as much information as possible of the reaction itself. This can be safety, this can be the actual how much you're producing, this can be the sustainability aspect, so we do a lot of solvent replacement, for example. So we don't actually have we don't do optimization. We don't do specific goals in mind. What we're trying to do is just maximize the information of the process so that clients can make the best decision possible.
Mm-hmm. We still have 1 minute 20. Back to Iris, yes?
Since you already have some customers, could you maybe give a more tangible example of how you replaced a certain solvent for a specific customer?
Yeah, so we actually have a patent on our solvent replacement for our technology. The idea is that we can screen process conditions very, very efficiently. So for each solvent, we can check how it's going to perform at different temperatures, different reaction times, different concentrations. And that way, we are able to screen the solvent space very, very broadly and hopefully find a new solvent that performs very well, or at least, if we cannot find anything, the company will have something to show regulators to say, I have to use this bad solvent because no other solvent works.
A specific example?
All of that is like private information. Yeah.
Are we done? Yes? Well, everything is clear. Thank you very much.
Thank you.